We're in our notes. So I'd like to look at, it's on the back of what we did last time. Let's see what's called. I'd like to look at example 5. Okay? Where it says more fun with transformations. So, and here's the original function. So, first question says, find the zeros of g of x. Now, g of x is the new function. This is the transform function. This is the original one. So if we said what are the zeros of this, well, that's easy. What are the zeros? X equals -3 and 1. Easy. Now, what does this transformation do? Changes the sign on x, which basically, if I'm the y-axis, it takes points over here and moves them over here, right? So it's like a sideways flip. So what's your wildest guess? What do you think the zeros of this function are? 3 and -1. It's that easy. Absolutely. Because whatever this thing looks like, and we can actually sketch it quite quickly, it's a negative cube. So it's going to start up here. That factor is squared, so it bounces off and heads down. That's F. Does that picture look okay to you? Now, what this transformation does is it takes this point and it flips it over to here. So -3 becomes +3, and -1 becomes, or excuse me, +1 becomes -1. Easy, easy. Now, question B, so that's a B, I'm going to change it. He changed it because there were some problems with it. So the question should say, on what intervals is g less than 0? So cross out the increasing part and just make it g less than 0. Okay, now let's look at the original since I've drawn it. Let's look at the original. What does this mean? G function less than 0 means y is negative. So let's look at the original. Where is y negative on the original? From 1 to infinity. Would everybody agree with that? Now, we're taking that picture and flipping it this way. So where's it going to be negative over here now? That's what g is. G is negative infinity to -1. That's exactly right. Because isn't this going to be coming up like this over here? So that's where it's going to be negative. Perfect. Beautiful. Okay. Now, using that same f, now we got a new transformation, and it's 2f of 3x. Take off the +5. We're just doing this. 2f of 3x. These are changes that Mr. Passwater made, so I'm confident they're good changes. There's made that. So 2f of 3x. Okay. Now, we want to find h of 1. All right? So if we want to find h of 1, what's it going to equal? 2 times f of 3? So wait a second. What's f of 3? Well, I don't know. I'll have to plug it in. So f of 3 is -2 times 36 times 2. What is that? -144? My math right? So what is h of 1 then? H of 1 is 2 times f of 3, so it'll be negative 288. You see how that works? If you want to find h of 1, you're going to put 1 in for x. Well, that's going to make you now work with f, and then just times it. Part B, we're changing this one too. So for part B, example 6, part B, we want to know what intervals h is greater than or equal to 0. On what intervals is h greater than or equal to 0? All right, so let's look at f. On what intervals is function f positive, greater than or equal to 0? So for f, it would be negative infinity to 1. Actually, I can include the 1 because it's greater than or equal to. So this is for f. Okay, what does h do to f? What does this do? Divides the x's by 3. So if the interval of the original is negative infinity to 1, what is going to be the interval for the transformed? Negative infinity to 1/3. Because what does this, right here, what does that do to your picture? It shrinks it. So what was at 1 before is now at 1/3. Now why did we not do anything with the 2? Because intervals are x's. And what does that do? Multiplies the height, right? So if I were interested in maximum or minimum or range, then I care about that. But it has anything to do with the x's. All right, one more, then we'll be, oh no, wait, see, what is the y-intercept of this function? I want to know h's y-intercept. Well, what's the y-intercept of this one? How do I find the y-intercept of this one? Plug in 0. So negative 2 times 9 times negative 1. So that y-intercept is at 18. Now, I'm talking about a y, right? I'm talking about a height.
Ignore me, okay?
I could never ignore you, Mrs. Mills. Okay. So that height is 18, right? So what happens to this function? All the y's get doubled. So where's the y-intercept for this guy? 36, because it's twice as tall as it was before. X's get divided by 3, y's get doubled in this function. All right, we'll do 7 and then we'll be done with this page, or this part of the stuff. Let's look at number 7. So now we're still using that. Oh, no, we're not. No, now we got a whole new function. All right, so now we've got this function. Okay, let's just look at that for a second. What do you know about that guy?
There's a hole.
There's a hole. Where's the hole? X equals 3, right? That's the X value of the whole. We could plug it in and find the Y if we needed it. Maybe we will later. How about asymptotes? We have a vertical asymptote at -4. Now, that's the original picture. Now we've got this new function that is -4 r of -x/2. I'm going to write that as -1/2x. That's the same thing, isn't it? I just think about it better that way. You can write it however you want. Okay, so before we get started answering the questions, what is this -4 going to do to the problem? It's multiplying the height by -4, what is that negative part going to do? Flip it over. So it's not only going to stretch it, but it's also going to be upside down of whatever the original was. Okay, what does this do? It divides the x's, or the width, I'll say width, divides the width by -1/2. So what's that negative going to do? Flip it this way. So what was on the right is going to be on the left and vice versa. And what's actually going to happen to the width? If we're dividing by 1/2, it's going to double it. Yep, so it's going to double the width, or double the x's. Okay, so what do the questions say? Identify any x values where this guy would have a vertical asymptote or a hole. So this was for the original. Now we're doing the same thing for this transformation. So vertical asymptotes and holes involve what letter, what variable? X, right? So if the whole of the original is at 3, where is the whole of the new one going to be? Well, what are we doing to our x's? We're dividing them by -1/2. So what's 3 divided by -1/2? So x equals -6. Your whole is going to be at x equals -6. If my vertical asymptote was at -4, where's it going to be now? 8. Hopefully it makes sense to you that the whole had a positive x in the original, so it's going to have a negative x in the new one. And likewise with the asymptote. Okay, last question here. Where is this function, this guy right here, where is he positive? Put your thought on it. Do we know the equation of K? No, we know how the original has been transformed to get it, so I suppose we could figure it out. But we have the equation for this guy, right? We have him. So I'm going to go ahead and cancel those out. And so we're basically looking at just this. Let's talk about where that guy is positive. Okay, so I'm going to draw my number line. How many dots? Look at your problem. How many dots am I going to have on the number line? this is a test question, you better know it. No, not 2 dots, there's gotta be
1,
3. Every parentheses gets a dot. So we got a dot at -4, a dot at -1, and a dot at 3. You say to me, but Mrs. Ford, those canceled out. Wait a second. They're still part of the problem, right? That's going to be a nice little open dot. These two are going to be nice little closed dot. Oh, no, not that one. That one's going to be a nice little open dot too. And that one's going to be a closed dot. That right there is on your quiz you're taking. We practiced it yesterday. You guys are stressing me out. Okay. Now, I want to know where that is positive. Okay? So let's just do some sign charting and let's see what we can come up with. So I put in -5. -5 is going to make me negative over negative. Does that work? Okay. -2 is going to make me negative over positive. No good. -1 to 3, let's put in 0. I think 0 works, doesn't it?
Yep.
And then I'm going to put in, I don't know, 5. Gives me positive over positive. That also works. Do you agree with that?
Yeah, absolutely.
So the shaded in part of my number line is where my original is positive. So R of X is positive in those parts. Now the question is, where is this guy? This guy. Where is he going to be positive? Right, now think about that for a second. Think about that. Luke?
Did you multiply the points on the number line by -1/2 to find where the points would be on K of X?
Okay, we got to be careful because I know it looks like they're multiplying, but
Or
the
divide it,
transformation actually divides it. So it's going to be a division problem. And you're right. So yes, at some point I'm going to do that. But there's something else I have to think about. What, Raina? Yes. Guys, we're talking about where it's positive. So if you think about that, whatever this shape is, let's see, okay, there you go. That's positive, right? What happens when I flip it over though? It's negative. So I found where the original was positive. But if I want the new one to be positive, don't I really want to know where that one was negative? Because where that one's negative, this one will be positive. Okay, so the interval I'm looking at is from -4 to -1. But like Luke said, those are x's. Those are x's. But they've been adjusted. How have the x's been adjusted? They've been divided by -1/2. So what do these numbers become? That one becomes an 8, and this one becomes a 2. So when I write my answer, I have to write 2 to 8. Because not only did it get flipped upside down, but it also got flipped sideways. Right? And when you write an interval, it must be written in order.
What about that 3? On the number line, because it's not part of the thing.
Oh.
Isn't it maybe, what do you do to get that number and then
That's what I gotta think about. I also because 3 is included in that interval.
I know you guys are taking safe.
Okay. No, I don't have to worry about it. I don't have to worry about it because, that's a great question, Xander. That is a great question. But I don't have to worry about it because R of 3 is undefined. Okay?
Yeah.
We agree.
Yeah.
So if this is 3, the problem doesn't exist.
Yep.
What would it take for this value right here to be 3?
It would take a -6.
Okay, is -6 in my domain?
No.
Don't have to worry about it.
Gotcha.
I gotta say, I'm not sure, but I have a gut feeling that because this number wasn't part of the original interval that we were looking at, that I don't need to worry about it. You see what I'm saying?
Yep.
But that's still, that is the best question I've had all week. That is an awesome question. Way too thick, Xander. Okay, all right, everybody clap for Xander, okay. All right, so now I'm going to turn back your last quizzes. I'd like to take a few more notes today, but I want to make sure I get this done. And so don't put your notes away. Please don't put your, oh, wait, you're not doing it. This is here. All right, so here we go. Joe Funk.
Thank you.
Bryce is not here. Hannah's not here. Kennedy's not here. Olivia.
I'll take a few as I know you. The question will be. I'll cherish that.
Patrick. Julia.
Best question all year.
Very good work, Jamie, over and over again. Emily. Uh-oh. Riley. Ellen, Addie. Okay, find somebody. Got your paper. Talk it out. Xander, Lena. Oscar. All right, so take a couple minutes and look that over.
Oh, wait, what did it get?
That's like this.
Yeah,
What did we get for 3 and 8?
3, I got B, 8, I got C, net.
I got D.
It does look crazy.
Yeah, I wrote one.
Oh, it's same. I put C. Yeah, I put C. Not the same.
How is the degree of this not?
We have the same ones. That's actually I get algebra. I just don't get it. It's just I just make stupid mistakes.
Ran out like 4x.
I I make like stupid mistakes, but on the next level, not
It's like M for an S.
Wait, chill.
that's not increased. This one I just straight up forgot how to do. Like I wasn't even, like I tried to guess.
I definitely gotta get up there.
Oh yeah, I have that one.
Bad Jack. Bad Jack.
Okay,
It's really gonna show.
Who wants mine? I thought
I got it wrong, so.
How bad,
wait
you
a
want?
second. You guys are still here, don't you have to go all the way to the south side tonight? She didn't left a couple hours ago.
You left at 1.
No, I didn't have it.
South side.
The day trip.
Okay, I'm gonna pick these back up, and you are all going to come in your office hours. Look it over. You wanna make sure that we are figuring out what we need to get on. No, it's 1-1 to 1-11. This is I'm not sure you can ever use limit notation too much. By the way, the next thing we do is going to be totally calculator dependent. Not this, but our next class period, totally calculator dependent, so make sure you have yours and it's ready to go. Okay, so what I want you to do real quickly is, if you go, so the notes we just finished, there's another page which we're not doing because it's just more of the same. Then there's a thing that is called building a library. Building a library. There are some basic functions, basic family of functions, or basic library of functions that we just need to be familiar with. Okay, these you've all done before. I'm pretty confident, maybe not these last two, but these you've all done before in second year algebra. So what is this? What is the name of that function? Does anybody know? It's called the linear function. Sometimes it's called the identity function. What does it look like? Yep, and you can go ahead and plot points if you want. Whatever works for you, I'm not going to require you to plot points. It is the 45 diagonal through the origin. So over 1, up 1, over 1, up 1, and so on, right? So it says, what's its domain, what's its range? Domain is negative infinity to infinity. Range is negative infinity to infinity. Absolutely. X-intercept, Y-intercept, same point, right? Increasing on, what is the interval where this thing is increasing? Negative infinity to infinity. It's increasing the whole time. All right, is everybody good with that? Okay, the next one on the paper there is the absolute value. This is the absolute value function. If you filled in your T-chart, you would see it easily, but does anybody remember from last year what the absolute value looks like, Kyle?
Is it like a V?
It is a V. And always remember that absolute value V. Absolute value is a V. But even if that, if you can't remember it, look what happens if you put in, well, obviously if you put in 0, you get 0. But what happens if you put in 1? You get 1. What happens if you put in negative 1? You still get 1? So you've got this V thing going on. A perfect example of an even function, because when we change the sign on y, or excuse me, x, it has no impact on y. That's when the even function is. This is an even function. Okay, so what's its domain? Negative infinity to positive infinity. X can be anything. What's the range? Be careful.
0
0 to infinity. And the 0 would be included. So for the range, it would be 0 to infinity. Perfect. Beautiful. All right. X-intercept and Y-intercept are both still the origin. 0, 0. And this one is increasing on the interval from 0 to infinity, and decreasing on the interval from negative infinity to 0. Everybody comfortable with that? Not bad? Okay. All right, the next basic function is the quadratic, or the squaring function. Anybody remember what he looks like? Parabola. That's a parabola. So again, if you want to plot points, you can. So 1, 1, 2, 4, and it too is an even function. Would you agree with me? In fact, the absolute value and the quadratic basically have the very same features. The difference is these are lines and these are curves. So what's your domain? Negative infinity to infinity. What's your range? 0 to infinity. X and Y intercept are both the origin. And like before, we are increasing from 0 to infinity, and we're decreasing from negative infinity to 0. Any question about those three basic pictures? Okay, now we have our cubing function. Anybody know what the cubing function looks like? It's a squiggle, but when you squiggle it carefully. It squiggles up like this. It's concave down till it gets to the origin, and then it becomes concave up. In other words, that point right there is a point of inflection, because the concavity changes at that point. So again, if that's a little mind-boggling, think about points. Clearly 0, 0, 1, 1, 2, 8. So here's 1, 1, and then 2, 8, way up high, so see what's happening? Now this is an odd function, because if I put in a negative 1, I get a negative 1, and so on. So changing the sign on X also changes the sign on Y. So it's an odd function. Domain? Negative infinity, positive infinity. Range? Negative to positive infinity again. Increasing? Negative infinity to positive infinity. That's an increasing function. Okay. The square root function. What can you tell me about the square root function? Anybody know anything about it?
The line that goes
One direction line. Now it's not a line, it's actually a curve, but you're right, Luke, because why is it only over on this side? Because X can't be negative, right? X can't be negative. So it starts at the origin. Again, think about a T-chart. They've invited you to make one. I'm not requiring that. No one requires you to do that, but it might help you. If you put in 1, you get 1. You put in 4, you get 2. If you put in 9, you get 3. So you can see why it's stretching out this way, because your X's have to be significantly bigger. By the way, this equation is y equals x squared. Its inverse would be x equals y squared. X equals y squared is a parabola that opens sideways. If I take the square root of both sides, what does that say? Y equals the square root of x. If we do plus or minus, we get both halves of the picture, but we only do the positive one because we want it to be a function. If we did the negative, we would have something that's not a function. So this shape is half of a sideways parabola. Joe, are you okay? Okay, you talking about that? Okay. So this is half of a sideways parabola. What's its domain? 0 to infinity, including 0. 0 to infinity. What's its range?
0.
Same thing. Where's it increasing? 0 to infinity. Right, this thing is always going up, never coming down. Okay, perfect. One more. These are the first 6. There's actually 12. That's all we're going to talk about today. Okay, anybody know what this one looks like? This is called the reciprocal function. This is the square root function. This is the reciprocal function. Anybody know what it looks like? Think about that for a second. What do you notice about it? What's its domain?
Can't be 0.
Can't be 0 for sure. So what does that mean? I have a vertical asymptote at 0. Would everybody agree with that?
Yes.
Okay.
So the domain would be negative infinity, I think, to 0 with the parentheses. And then 0 to infinity.
I like that. That's the domain. X can be anything in the world except 0. Okay? Maybe we're awesome. What, go ahead.
Well, I know on the right side, it's going to start from the top, like the top right, quadrant 1, yep, and it's going to start close to 0, and it's going to come down, and it's going to come down like an L.
How did you know that, Xander? That's exactly what it looks like. How did you know that? What was your thought process?
I was kind of just throwing some stuff in there, and I realized like once you get to 10, it'll be like 1/10. But if you start with like a .001,
exactly.
it'll be much
so that we were sitting here. Some of us were struggling with what does this thing look like. So in his head, he's plotting points, which is always what you should do. So he said, if I put in 1, I get 1. Okay. If I put in 2, I get a half. 3 gives me a third, so the further I go this way, the smaller my y's get. But if I put in a 1/2, I get 2. And if I put in a 1/3, I get 3. So the smaller those x's get, the bigger the y's get. Does that make sense to you? Now, what else? Could x be negative? What's going to happen if you make x negative? It's just going to make y negative. Yoo-hoo, another odd function, right? So where's that point going to be? We're going to have that very same shape because it's the very same points, but it's going to be in quadrant 3. Does it make sense that there appears to be a horizontal asymptote at 0? Yes, because why? Think quiz tomorrow or whenever it is. You got an X on the bottom, you don't have one on the top, so the limit and behavior is always going to be to 0, right? Always. Okay, perfect. Domain. Oh, already did it. Range. Same thing. Because you can come up to 0, but then you gotta skip it and go on. Increasing. Never. When you draw this, which way's your pencil going the whole time? Which way's your pencil going the whole time? Yeah, that's a decreasing function. Decreasing. So it isn't increasing anywhere. It's decreasing on its entire domain. Okay, now quickly, I'm going to throw one more problem at you. This will be it. I want you to sketch using kind of some of the ideas we just talked about. I want you to sketch this. On a coordinate plane, I want you to sketch that. So which of our basic functions are we going to use? A v. And these are the transformations that we've been talking about. So think about what's going to happen. Here's my v. What's going to happen to it? Think about that for a second and see if you can sketch it. All right, quickly, what'd you come up with? We're going to run out of time here. What happened to your v? Let's make a list. What did this do to my v? So what did this do? Multiplied what by 2? This multiplied the height. Think of this as your function. Isn't this your function? What does a multiplier out in front do? Multiplies your height. What did this do? Move to the right 2, and then this took it up 3. Now, let's kind of get in the habit of doing the order of operations when we do those moves. So this is like a parenthesis. So it's going to go left 2, or excuse me, right 2, then stretched 2, and then lifted 3. Okay, where's the vertex? Number V. Where's the vertex? 2, 3. Here it is. So it's emanating from 2, 3. This number is like slope. Multiplies the y's. All right, 1.12 is due on Tuesday. We also have a quiz on Tuesday. That quiz should have been today. Okay, everyone? Have a good weekend. Be safe and smart.
Thank you.
Go Animals and Rat Pack. Or what were you? Wolf Pack.
Rat Pack.
No, Rat Pack, please.